Welcome to Lecture 3 in Introduction to Applied Internet of Things. This is Programming Part 5 and we are going to discuss I2C and SPI. Sometimes I just say I2C, but it's normally pronounced I2C. First, we are going to discuss the read, evaluate, print loop, REPL or REPL. It's sometimes it says shell. In Tony, it's like a simple command window where you can type one line at a time or copy paste if you like that one. I like it. And you can also see prints from scripts. When we type print in a script, we will see it in the shell. You can test your ideas quite quickly and you can use it for troubleshooting. In this case, we're going to scan the I2C device I have connected one device to. So here is the script. I have copy pasted it, but I can paste this script inside, and in this case I will see the hex value, and it could be a good technique in troubleshooting. And the hex numbers is sometimes used to communicate with sensors and devices. Here you can see what I have connected. You can see two devices. It's the same device. I will sensor the air pressure with this one, and this one is use I2C, and the same device here is using SPI. And you can see that the I2C one uses 4 cables. One power, one ground, and then one clock and one for data. And this SPI use 2 more wires. More about that later on. So I will paste my script. And press enter. And then you see, in this case, I got the number of this sensor. It's a hexadecimal sensor. Could be sometimes used in your code, or sometimes you have to use it in troubleshooting. The inter-integrated circuit, I2C, uses, as I said, 2 data wires, and one for power and one for ground. And you can use these 4 wires to connect multiple devices, up to 128, I guess. And one wire is for data and one is for clock. And on the Pico you can use 2 I2C buses at once. The first one is called 0 and the second one 1. And then you can use most of the pins. In this case I use the 0 and 1, and you can see on your data diagram of your pins that you can use the 1 is for the data and the pin 1 is for the clock. But as you see on your pinout diagram, you have a lot of choices, but you can normally use 2 buses at the same time. There are a lot of commands. We have the scan command or the method to get a list of devices. It's a method quite handy to use. You can use the read from, write to, read from mem, or write to memory. Is it complicated? Yes, that's because that's why we use a library or a module to communicate. There are modules or libraries for most things. In this case, we will use a BMP 280. It's a small sensor. You can see it here once again. That measure 2 things. First, air pressure. It's handy for weather data or for altitude. It can also measure the temperature. And I bought a version that's both available for I2C and SPI. So in this case I downloaded a library. In this case it's called BMP280, and just downloaded it into my Pico, and that makes the coding a lot easier. You can often find modules or libraries to download for your sensors. And on this one here you can see that I connected the clock with the green one to the pin, this second one here, and to the data, the yellow line here, to the first one. I will start with import from machine import. Normally we just write pin, but now we also import I2C. So these two modules we will import from machine, and I will import this one as well, the BMP280. You see I have a lot of things here downloaded on my Pico. Import. And I will import time as well for using the sleep. If I want, instead of import time, I can from time import sleep, and then I can just write sleep 1, for example, 1 second. In the, if you don't just write import time, I have to write time dot sleep 1. So if I want the second line here, the smaller one, I have to use from time import sleep. I will start with create a I2C variable, and I use the I2C, and here I have to name it either 1 or 0. I will use the first one, and then I say the clock one, SLC, is on pin 1, and the data, SDA, is located on pin 0. And I will also use a frequency, not always necessary. I will use 400,000. Now I will use this to connect to my sensor. I call it sensor, and use the BMP 280 and I can use this. Instead of writing this, I can just write this one, but then I have to change this from BMP 280 import. This looks more clean. I will say that I will locate this one on this. I have just configured. Now I will use a while loop, while true, and then get some temperature, sensor, get, and I get the pressure as well. And I will use the print command here. Print, and I will write temperature, and then use the comma, and then say and use the comma, and just use C, and then I will the same with pressure. And then I will use a short sleep for 2 seconds. And then I test the program. Hopefully it will work. Just a misspell here. And you see here, you get your temperature and you get the pressure here in the shell using the print command every second. As I said before, in I2C you can have multiple devices in serial, and to show that I will also connect a LCD screen, a 1602, that means 16 characters each row, and I use 2 rows. It can often use either I2C or SPI, and in this case I will use I2C, and I also need an external library for this one. As you see before, I have downloaded that one. It could be different on different screens, so look at your documentation and use the one you need. For a screen, of course, you need some strings, and a string is a piece of text. And as we learned before, you write the text within single or double quotes. But sometimes you need a special character, for example, for a new line. And if you Google, or you can see that you should use the \n for new line, but it doesn't work on every 1602 screens. Sometimes I will have to use a move to function, where you move it to the right column and the right row. So if you have your LCD, you use the command LCD, normally you call it that one, and put string, and have a string here inside. But sometimes you want to combine text with a number, you can use the comma, but sometimes you will have you want to use the plus, the add sign. It's called concatenate. That means add 2 strings, but you can't concatenate a string and a number. It doesn't work, so you have to type casting. And doing that one, in this example, I have a variable called age, that's 12, and then I use the string. So I wrote str, and in parentheses I will use age, and then it will typecast to a string, and then I can use the plus signs to add them. If you're going to use a lot of strings, a recommendation, I will show one case of them, is to use the F string. In this case, I will connect the LCD screen in series with the pressure sensor. So to make that work, it will look like this. So here I connect it to the data and the clock here and some external powers. In this case I will connect it here on the side. It could be looking different. Now we are going to program it. I will start with import the I2C LCD library that I have downloaded and installed on my Pico. Then I will configure it. I call it like that, and I will use the I2C LCD, and I will use the same I2C, this variable, and I will use hardcode what number, and I don't know that, so I have used a script here. I will scan here. I will stop this one and I will run this script, and I see here is the number 27 in hex. I will go back here. So the scan comes in handy, and this is 2 rows and 16 characters each row. So now I can use this one. So instead of printing, I will use this, so it will not write. So if I run this one, you don't see anything in the shelf. Instead we will use this one. LCD.clear, that clears the screen, and then I will move, because this \n doesn't work on my LCD, move to, and then column 0 and row 0, and then I will use LCD print put, and there I will write temperature, and then I will add this and I will move to the next line. First column, second row, and then I will copy this command, and instead of temperature I will write pressure, and hopefully it will work. I have this sleep, but I will move this one. And maybe you can see here, so you see the temperature and the pressure located on the screen instead. So this is how this LCD screen works. And here you got the code once more, and in this case I show how a F-string works. You can look at it, and if you think it's looking more beautiful, please then this code, forget that one, but you can read more about it and learn it by yourself. The SPI, the serial peripheral interface, is another communication protocol used to send data between a microcontroller, in this case a Raspberry Pi Pico, and sensors, maybe displays, memory chips, etc. It uses 4 wires plus power and ground, so totally 6. And 1 for microcontroller out and 1 for microcontroller in, 1 for clock and 1 from chip select, who tells which device to talk to. Since this uses more wires, it's faster, but it's also a little bit more complicated. In this case, I used the pin 16, 17, 18 and 19, and you can see the command to create an SPI variable is more complicated. And then you have to have this chip select or slave select. Sometimes it's called SS, that means slave select, on pin 17, and put that in out and set the value to 1, that means inactive. And then in this case I have another library for this BMP280. I call it BMP280 underscore SPI and use that one. And we will test this one out. The hardware setup is more like the same, but you have 6 wires instead of 4, so it takes more of your pins if you use an SPI. In my case, I prefer I2C because it's easier. But we will test this one now. So it's this one over here, and as you see, it's more wires connected to these ones here. Yeah. So I will use this one instead of the I2C. First thing I have to do is to import it, the SPI, like that, and then I have to import this library. And I will connect first the SPI. I will do this here. So I copy paste this line. It's the first one. You have two this one as well. The clock is on 18. The output and the input is on 19 and 16. And the one I miss is the chip select. I call it like this, and that is on pin 17, pin out. And I set the value to 1, and that means high, inactive. Then instead of using this one, I will use a sensor, I call it sensor SPI, and that one we'll use this one. And then I will use this one that I created and this chip select. So this is the, you have to have 1, 2, 3, 4 commands instead of just 2 for the other sensor. But we can use it almost the same. I copy paste some commands here. So I have to fix this one. So I read it, temperature here, and then the pressure, and then I print it so it will be shown on the shell instead. So hopefully we make that work. And here you see the SPI sensor shows some temperature and pressure. So it's just mostly the configuration that are different. To use it is more or less the same. So in this lecture, or this part, we used the I2C interface to communicate with a sensor for pressure and temperature, and also a screen. And then we used the SPI interface to communicate with another sensor, the same sensor. Hopefully it shows more or less the same pressure and temperature, almost, I see. To show that you could sometimes use I2C and sometimes you can use SPI. SPI you should use if you need the speed. I2C is often a little bit more handy, so use that if you don't need the speed. That's all. The code you can find in the slides, and yeah, it's just copy paste if you want to try it out, but don't forget to download the libraries and install them on your Pico. Have a nice day.